Welcome to Pallavi Online Tutorials. Our channel specializes in electronics, engineering maths and K-12 maths. Right now, we'll be talking about basic electricity and electronics engineering, delta to star transformation. When do you go for delta to star transformation in case of resistors? Now here you can see that these two resistors had been in series, had this third resistor may not have been there. In this case, the resistors are neither in series nor in parallel, then you go for delta to star transformation. What is a delta and what is a star? See, delta is nothing but a triangle. As you can say that ABC is delta. And what is a star? A star is something this kind of a structure. A star is this kind of a structure. This is star. When resistors are connected either in delta or in star, you go for delta to star or star to delta transformations. Coming back to our point, how do you convert delta to star in a very neat way? That is, you should not be committing any mistakes while converting from delta to star transformations. The first thing we have to identify in a problem, we have to identify the delta. Like in this problem, my delta, in this derivation, my delta is A, B, C. I have named the delta as A, B and C. Similarly, the resistors in between these two AB are named as RAB. Resistors between the branch AC of the delta is named as RAC. Between B and C, the resistor is named as RBC. Having said so, I have to convert the given delta ABC to a star which has O as the center point and has three resistors RA, RB and RC. We have to convert the delta ABC into this kind of a star. How do you go about doing that? I am given this outer delta with ABC with three resistors RAB, RAC and RBC. Converting this to star, how do I apply the formula for RA? What is the formula for RA? Now RA is the resistor. RA is the resistor between RAB and RAC. So how do you use it? RA will be equal to RAB into RAC upon sum of all the three branches of the delta, RAB plus RAC plus RBC. This is about RA. Now can someone think about what will be the value of this RB? This value of RB will be the product of RAB and RBC upon RAB plus RAC plus RBC. There is no need to by heart anything as such. Since RB lies between RAB and RBC, we are taking the product of RAB and RBC and upon sum of all the three resistors. That is the advantage of naming the deltas properly. Okay, it's to talk about RC. Look at RC. This RC lies between RAC and RBC. What will be the value of RAC? Product of RAC and RBC and upon sum of RAB, RAC and RBC. See, this is the value of resistance RC. So we have successfully converted given delta ABC into this star. Now what can we do further? What is more important? It is more important that you connect the values of this ABC. RA should be in the proper place, RB should be in the proper place and RC should be in the proper place. All the three are not interchangeable. I repeat, all the three are not interchangeable because unless and until the three resistor values are equal, all the three resistors are not interchangeable. So you have to name the delta properly and accordingly place all the resistors. Having said so, we go forward to star to delta transformation. What is star to delta transformation? It is exactly the reverse of delta to star transformation. You will be, that is, you will be given a star, internal star, that is Ra. You will be given the values of, suppose if you will be given the values of internal resistance Ra, Rb and Rc, you have to convert it into the outer, find out the outer three resistance Rab, Rac and Rbc. Fine. Now what should be the we have to given Ra, Rb, Rc, we have to find out Rab, Rac and Rbc. Okay. Now this resistor Ra, the resistor Rab, the resistor Rab is connected to two resistors Ra and Rb. What should it be? Should it be its value? Rab is equal to Ra plus Rb plus Rb upon Rc. Resistor Rb is equal to resistor Ra is equal to the product of resistor star to delta conversion. Rab is equal to sum of Ra plus Rb plus Ra into Rb upon the third resistor, that is Rc. I repeat, resistor Rab is equal to sum of Ra plus Rb, product of Ra plus Rb upon the third resistor Rc. Similarly, what can you say about Rac? Rac connected to two resistors Ra and Rc. Rac is equal to Ra plus Rc plus Rc upon the third resistor, that is Rb. Okay, so on and so forth. What can you say about the third resistor in the delta, which is Rbc? Rbc is clearly connected to Rb and Rc, so its value is Rb plus Rc plus Rb into Rc upon the third resistor, that is Ra. Now again I am repeating that the values of Ra, Rb and Rc cannot be interchanged. If you are drawing the delta ABC, its corresponding Ra, Rb and Rc should be drawn accordingly. They cannot be interchanged in any case. Your problem will go wrong if you interchange any of these resistors, unless and until all three resistors are equal. Going forward to the next point. Now to simplify this point, we will take one problem. Which problem is determine the this is about the Mumbai University. This problem was asked in Mumbai University December 2009 paper. Determine the resistances between A and B in the figure shown. Identify what is A and B. This is capital A and capital B. These are the two terminals between which we have to find out the equivalent resistors. Now people, please tell me, you can see that there are two ways this can be done. You have to find out the delta and the star in this. Afterwards, this is the delta, external delta. This is the internal star. What should we do? Another important thing to be decided somewhere is that to convert the outer delta into star or the internal star to delta is a very big question, which is to be converted. Now firstly, if you convert the internal delta, internal star, then these terminals A and B will go away. But this should not happen. A and B should not go. This resistance OA between the branches OA should not go. So what we do, we convert the external delta into star. Understood the reason? We should convert the external delta into star. For my convenience, I have named this delta, external delta, as A, small a, small b and small c. I have purposely used small a, small b because here they have given the no terminal name as a and b, capital A and B. Next, converting the outer delta ABC into star. This outer delta ABC I have converted into star. Now conversions, see what I have done here over here. What is this diagram? How do I get this diagram from this? Observe these two diagrams very carefully. See, this triangle ABC, outer delta ABC, I have just removed it outside. I have just removed it outside. This terminal A, if you see this terminal A I am connected to terminal A, terminal B I am connecting to terminal B, and terminal C I am connecting to terminal C. Nothing much done. Now after this I get a plain delta in which I can place my which I am supposed to convert it into star. Applying our usual formulas which I just explained to you earlier, I get the following values of resistors. I get RB value, this RB value as R by 2, RA value as R by 4, and RC value as R by 2. After getting these values, see very carefully this triangle. I am cutting the delta. This delta, these three branches will go away, and what only remains is this star. I have to draw a new diagram to indicate this. Now again these two terminals remain the same. A remains the same, B remains the same, and C also remains the same. What should you do further? I should first draw my figure neatly. That is, I am connecting the AA terminals as it is. This C which was there C, I am just taking this C this side, R2. This B which was there like that, I am just redrawing it in a new fashion. Further, I can see that many resistances are in series and in parallel. These two resistances are in series, 2R plus R by 2. I have found out to be 5R by 2. This 2R again is in series with this R by 2. I found out 5R by 2. These two resistance 5R by 2 and 5R by 2 are in parallel. Previous sessions I told you R in parallel with R is always R by 2, 5R by 4. Okay. So we get a simple neat diagram whereby these two resistances are in series, which turns out to be 6R by 4. 6R by 4 again turns in parallel with 2R, which turns out to be 6R by 7. 6 which turns out to be 6R by 7. Thank you very much.